depending on the location of that triangle. We call it like upper triangular matrix or lower triangular matrix. But basically, okay, it's something like this. Okay, we always use like diagonal part of the matrix as like measure. Okay. If all the elements here are 0, okay, below the diagonal elements, then we say this is upper triangle matrix because like you only have like elements, above the diagonal. Okay. On the other hand, if all the elements here, okay, above the diagonal are 0, then we call such a matrix as a lower triangular matrix. Okay. So for n by n matrix, okay, we sometimes, it's not always, but sometimes we could, okay, be written as a modification of, as a product of like the lower triangular matrix and upper triangular matrix. Okay, so if that happens, we say, it's a LU factorization of that matrix. This is an example. You can see this matrix is the result of this modification of this matrix and this matrix. And this one is a lower triangular matrix. As I say that. All the elements above the diagonal are 0. And this is the upper triangular matrix. All the elements below the diagonal are 0. Okay, so this is LU, okay, factorization of the matrix on the left hand side. I'm not saying we can do that. Do this like all the time, but we could do it like if there's some nice problem. Okay, but before we go on to talk about how we obtain the LU factorization of matrix, okay, let's try to motivate this thing a little bit. Okay, why do we want to factorize the matrix as like a product of lower triangular matrix and upper triangular matrix? Okay, so assume your matrix, you are using the matrix, okay, it's a square matrix, okay, to solve like a system of linear equation. So it's going to be something like that, right? AX equal to B, right? So if A can be written as lower triangular matrix and the product lower triangular matrix and upper triangular matrix, then obviously if A becomes LUX, right? LUX equal to B. I mean, here L stands for that lower triangular matrix. U stands for that upper triangular matrix, right? And then, okay, because we know like LU, both of these matrices are square too. Okay, they are square too. So, you can assume UX equal to Y. That must happen, right? That must happen. Okay? And you can say original you have like x1, x2, x3, right? So now that y becomes y1, y2, y3, right? But of course you don't know what that y is yet. Okay? But if you let ux be y, now you have, Ly equal to b, right? You have Ly equal to b. Okay? So remember, like this is a lower triangular matrix, and all the elements here are zero, right? They are all zero. All the elements here are zero. So you have y1, y2, yn equal to b, right? Your b is b1, b2, bn, right? It looks like this, right? So what will be the first formula, first linear equation from here? The first linear equation is going to be this one multiplied this one equal to b1, right? Right? But remember, this is like lower triangular matrix. So all the elements except the first one are zeros, right? So in other words, you are going to get something. Assume this is something like something times y1 equal to b, right? All the other elements are gone. All the other yi's are gone. So you can immediately get what y1 is, right? And then the second equation, you are going to end up with only two terms on the left hand side, right? y1 and y2. The other term again are all zero, but you now already know y1, right? So in other words, you have again one unknown only, right? So you can immediately get what y2 is. So you can repeat this process for all the yi. Okay, so for the Ly equal to b, Ly equal to b, you can easily get your y1, y2, y3, and then you put that yi here. Ux equal to those yi's. You can, similarly, you can easily get what those xi's will be, because the ux is like lower triangle are zero, right? This part is zero. If this part is zero, what happens is that, of course, if you look at the and here we have y1, y2, yn. I mean, now you do the opposite. Okay, you try to solve the last equation. Okay, you can obviously see that except the term xn, all the other terms are zero on the left hand side. So you can easily get what xn is. Okay, and you can do it from the bottom to the top. You get those xi one by one. So basically, you can solve this system linear equation in these two steps. Okay, systematically, if you know that A can be decomposed as a factorization of lower triangular matrix and upper triangular matrix. Now, okay, once we know, okay, well, there's some benefit of doing like this factorization. Then, okay, how do we get this job done? The important point here is that, okay, the product of lower triangular matrices are still a lower triangular matrix, right? You can give it a shot, okay, and try to, this one, I don't think I need a proof, okay, but if you do need a proof, like you can write the product, okay, of two matrices according to the equation, you write it down, and you will find that all the elements above the diagonal, okay, will be zero if the previous two matrices that we multiply are lower triangular matrices. Okay, so this can be easily proved. By the way, this looks like a good quiz problem. By the way, here just return you the quiz, right? Okay, the graded, your grade, so you can see your grade. Of course, if you have any problem with the grading, as I mentioned that at the beginning of this class, please talk to TA. Okay, talk to TA, and of course, like if you cannot resolve the dispute with the TA, please see me. Okay, I mean, we will continue this like throughout the class. Like so, today, okay, tonight, okay, actually, I'm going to upload the practice question for the second quiz. Okay, and and so on. Okay, so we will have like 1 week. I upload the practice questions. Next week we will have a quiz. Okay, and the quiz is always held near the end of the class. I mean, it's just for some student who cannot wake up at the early hour. I know like you guys are good. Okay, I mean, when I was a student, I couldn't do that. Okay, 9 a.m. is too early for me. Okay, I mean, I guess a lot of students are similar. So I try to be nice to those students to hold the quiz near the end of the lecture. But if you miss it, well, what can I say? Okay, and also a student came to me like last time after we held the quiz. Okay, a student came to me saying like, I have doctor approved. Okay, so I missed that quiz, like because of the medical reason. I understand that. Okay, but remember, we have 6 quizzes, right? We have 6 quizzes, and we will only use the 4 top highest grades. Is that right? According to our syllabus. Okay, so if you even for valid reason you miss quiz, even for valid reason you miss quiz, then okay, we will use the same, because like it means that you drop that score. You know what I'm saying? Okay, so it will really affect your grade until, for example, you have a good reason to miss like a number of quizzes. If that's, I don't think that's likely, but if it really happens, I mean, yeah, I will just grade. I will just give you like quiz grades according to like the quizzes you took. But that's basically like not the ideal case, right? So still, I mean, in any case, I suggest you try your best not to miss the quiz. Okay, I mean, for medical reasons, I mean, those the opportunity for you to drop the creases. I mean, kind of, it's already a buffer. Okay, you can use that, if you have medical, the very reason that you're not attending that piece. Okay, let me make it clear. Okay, yeah. So it shouldn't affect you. Okay, unless you miss it multiple times. Okay, so come back to our lecture. Okay, so how do we do this LU decomposition? So if you know that lower triangular matrix stays as a lower triangular matrix, then you know, okay, when you are doing like, what should I say, like, you are trying to convert your matrix into row echelon form by using the elementary row operations. Remember, I told you last week that those elementary row operations, okay, can be understood as the product, right, of the elementary matrices. Okay, so say you take from A, you take K elementary row operations to make a row echelon. Row echelon form is pretty much an upper triangle, right? By the way, row echelon form is pretty much upper triangle. Okay, remember, like, the leading element has to be non-zero, and all elements below that will be 0. So that's the row triangle, right? So in other words, so you take like action 1, action 2, and so on, action K, to make A to be upper triangle. Then you see you can write it like this, right? According to our discussion last week. Okay. So if you look closer to those like EIs, okay. If those EIs, E1, E2 to EK, if those elementary matrices are only addition and multiplication by scalar. Okay, addition means like what? Means you multiply a row by something and add to another row. Remember? That's addition, right? Multiplication means you multiply a row by a scalar. Right? Okay, and their corresponding elementary matrices are right? You can see this is you see this is like an elementary matrix for multiply one row by a scalar. This is an elementary matrix for multiply the first row by -2 and to the third one. You can see these two must be triangular matrix, right? They must be triangular. They must be lower triangular matrix, right? Right? Except the first one. The first one, like swapping like 2 rows. Yeah, that's not lower triangle. Okay, but the second one, the second type and third type. These 2 types of elementary matrices, they happen to be lower triangular, right? And if you consider their inverse is lower triangular as well, right? How do you undo the second one? Remember, I said, okay, the second one you just multiply the first row by 1/2, right? 你怎么样把这个先去掉？把这 okay. You want to multiply the first row by 1/2 to convert this one back here. So that's pretty much like you put the 1/2 here, all the other to the 1. So it's a lower triangular as well. And how about this? This one is like you multiply the first row by 2 and add to the last row. So it's going to be almost the same, except this negative 2 becomes positive 2, right? So there, not only these two types of elementary matrices are lower triangular, their inverse are also lower triangular, right? 对不对？不只是它们是 lower triangular， 而且它们的 inverse 反函数反矩阵也是 lower triangular。So once you understand that, okay, because we have this, right? We have this thing. And if these EIs are those two types only, then we can let an A to be the inverse of, we want to cancel out this, so we have to multiply EK -1 first, and then EK -1 -1, and so on. So the order is reversed, it becomes something like that. Multiply U. And as I told you, okay, the inverse of those two types are lower triangular. So the multiplication of this lower triangular matrix stay to be lower triangular. So now the multiplication of this will be your L. Okay, will be your L. Got it? So basically, like as long as your conversion from the original matrix into the low echelon with the operation in between, okay, during your conversion does not involve swapping two rows, then your matrix could be factorized into this LU form. Okay? 了解吗？只要你的你从你的原来的 matrix 转换成 row echelon form 的过程里面，没有那个换两列的那种两个 row 的这种情形的话，那你就可以根据这个讨论，你就可以把它写成 LU decomposition, LU factorization. Okay. Let's have a look at an example. First, let's try to find an LU factorization of the matrix this one. So from here, it's actually relatively easy.
out.